mining is entering its next digital era, where data, AI, and connectivity redefine how raw materials move from mine to market.
Digital innovation is transforming the entire raw materials supply chain. Digital product passports ensure traceability and compliance, while AI-driven decision systems reshape planning, performance, and sustainability.
Across mining operations in Africa and Latin America to EV manufacturing in Europe and Asia, data centralization, digital twins, and intelligent planning tools are revolutionizing efficiency and transparency.
For small and medium-sized mines, digital integration is unlocking access to advanced technologies once limited to major players, leveling the field and boosting competitiveness.
Digital transformation is powering the future of mining, smarter, faster, and more sustainable.
Good afternoon, everyone, and welcome to session 7, Mine to Market 4.0, Digital Innovation and Raw Material Supply Chain Management. We have ahead of us 50 minutes with 4 speakers of very interesting presentations. My name is Arturo Gutiérrez del Olmo. I am Technical Director of Mine Waste Engineering at SLR Consulting, and I am delighted to moderate this session featuring forward-looking leaders driving technological transformation across the mining value chain. First of our speakers is Ella Cullen. Ella, please, if you don't mind. Ella is co-founder and CMO of MineSpider, where she drives innovation in digital product passports and traceability platforms. She is an UNECA blockchain traceability expert, and her work has been recognized with awards in Women in Mining 100 and Women in Tech Europe 2025. MineSpider provides blockchain supply-based chain transparency solutions, helping companies track and verify provenance, ESG credentials, and carbon impact raw materials through digital product passports. Without further delay, Ella will talk from mine to manufacturer digital product passports in action. Thank you, Ella.
Good afternoon, everyone. Hope you all had a lovely lunch. So I'm Ella. I'm co-founder and CMO of MineSpider. MineSpider is a blockchain traceability company. So basically, we track minerals along the supply chain. And we do that using digital product passports. Now, I'd like to see a show of hands who knows what a digital product passport is or uses one in their business. Okay, nice. So we've got like 20%, 30%. So I hope for those of you who aren't familiar that this is giving you a baseline understanding. And for the rest of you, this is covering a few more use cases that you might not have heard of, actually. So today I'm going to be covering compliance, efficiency, branding, investment, and a couple of others as to why people deploy digital product passports. Who do I aim at? Okay, so what exactly does a digital product passport do? Well, it's a digital identity for a product. And essentially, we connect this digital layer to the physical layer, which may be a material, a shipment, a product, with a QR code. We can also use more advanced physical trackers, but usually a QR code is actually enough. And it gives an overview of basically where the product came from, so its origin, traceability, all the actors that it's passed through on its way along the supply chain, ESG performance, carbon footprint, obviously scope 3 is very interesting when we start talking about supply chains, and recycling and reuse, so how to better utilize secondary materials, for instance, at the end of useful life. So DPPs make traceability visible and verifiable along the whole supply chain. So for us, this started back in 2018 with a single metal, which was tin, and a very big idea. So the original idea was basically to try and end conflict minerals. I know, very, very heroic. And then we actually were very lucky to start with an amazing consortium of partners. So this included Minsur, Google, Cisco, SGS, and Volkswagen. And what we're doing here was end-to-end traceability, so checking tin from Minsur, which many of you will know is the second largest tin producer in the world, to these end OEMs. And we successfully, for instance, tracked tin from Minsur to a Google Pixel phone in the US. But this is when we encountered our first kind of questions from the users, and that one was, how do we keep our data private? You know, we don't want to share our secret source along the entire supply chain. So we built basically a private layer and a public layer of data visibility into our digital product passports. So when you go to upload a PDF, you can basically choose who you send it to. If I'm sending it to my partner with bills of lading or invoices, I can keep that private. And if I want to include like ESG metrics or carbon footprint or ISO standards, I can make that public information. And in the same year, we also started expanding to Africa, working a lot on mine-to-smelter chain of custody. So we continue to ramp that up, and by 2023, we actually tracked 10% of the world's tin with digital product passports. Interestingly enough, Minsur actually mostly uses DPPs for branding. So they want to differentiate themselves from other regions of illegal mining in Peru, such as Madre de Dios, and they want to showcase the huge efforts that they make to be responsible in their production. And they also, as another use case, use it a lot for internal traceability. You can imagine for a company of their size, a lot of the time they don't actually know where things are going when it goes from San Rafael mine, 4,000 meters in the Andes, to the Pisco smelter. They want to learn how to optimize and make those processes more efficient. So DPPs also allow them to understand the internal flows. And then in 2018-19, we got hit with EU battery regulation. And this actually comes into full force now in just over a year, like in February of 2027. And this was the first time that we had kind of a passport that needed to follow a very clear structure. So we consider digital battery passports kind of like a subset of a product passport. And we know what data needs to be in it in order to sell batteries or to produce batteries in the EU. And these days we work with companies like Renault and Ford and grants to help them capture key data about their batteries, and also e-bus producers like Temsa or lithium-ion battery producers like Microvast. So I was just talking before about implementation and how we scale compliance with one of my colleagues here. And what we realize is also for a company of our size, we're still relatively small, it's impossible to enter markets like China, right? We know how important China is to the world in terms of both minerals and batteries. So for us, this means basically scaling DPPs by partnering with one of China's largest certification and battery testing companies, which is called PTL, and they have a network of about 3,000 battery producers in China. And in India, that looked like partnering with Tata Elxsi, which is obviously part of the Tata Group, and allows us to basically, allows them to white label our product passport and resell to their clients in India and globally. Now, coming back to Europe, there's obviously a lot of discussion about Europe being a big regulator, and maybe in some way that works in our favor because we support a lot of that work. We know that Europe doesn't have a lot of primary materials, and that it's very focused on ensuring that the ones that it does have continue to maintain in Europe, continue to stay in Europe. So obviously we have the EU Green Deal and a huge focus on circularity in the EU. And digital product passports are really at the core of enabling that. You know, they make circularity more measurable, more verifiable, and more scalable. So just as an example, we manage around 32 million as a tech lead for projects that focus on like circularity. So BATRAW is basically how to pull more minerals from black mass from batteries. Recirculate is how to like track second life of batteries. Apollo is for PVs, and Return is for e-waste. So the goal behind all of these is basically how do we keep critical minerals in the EU and ensure that we actually track them as they enter back into the supply chain and are used in further second lives and third lives. But actually the most exciting use case for me is not compliance, it's not branding, it's not efficiency, it's capital and it's investment. And what we see this year is DPPs as investment infrastructure. So we know that there are a lot of geopolitical concerns about mineral production, mineral sourcing, mineral processing, etc. And we also know that there are a lot of countries looking to reduce their dependence on certain regions. So how do we go about this? We partnered with a company called Tethys, and they have a really interesting business model. What they do is work with 300 mines in Central Asia and Turkey, and they get them to a certain standard of ESG, for instance, so that the EU can invest in them. And we know that the EU has earmarked about 12 billion to invest just in Central Asia. So once they reach this certain standard, then the EU can invest in them and source critical metals from these mines in Central Asia. And what we bring to that is traceability. So this is now becoming one of the foundations of how they can gain investment or market access. Because if you think about it, if you get this mine up to a certain standard, you don't want product laundered in from a neighboring mine that isn't up to those standards, or from a neighboring country. So it's really setting a foundation of transparency, traceability, and ESG that we can, as investors, as manufacturers, and so forth, we can trust. And maybe another interesting use case there is Rare Earth Ventures, who's also our partner in Australia. I think it was only 2 days ago now, but basically Trump and the Australian Prime Minister, Anthony Albanese, sorry, I'm from New Zealand, not Australia, basically signed a deal to give the US more access to critical minerals and rare earths in Australia, worth about $8.5 billion. So of course you need traceability to ensure that those minerals are actually coming from Australia and not from another region in the world. So long story short, that is the most exciting use case that I foresee, is we're bringing transparency, traceability, and enabling capital to flow into new regions of the world using digital product passports. So these are some of our partners. I would love to hear your questions after this talk. I know we have some time for Q&A, and if not, please feel free to drop me an email. Thank you so much.
Thank you, Ella. Thank you very much. Ella Collin from MineSpider. The next speaker here is Lorelei Ratuszniak. She's a director of mining relations at MICA. Lorelei will talk about mining's digital inflection point, AI, vendor data, centralization, and future of technology adoption. Lorelei is director of mine relations at MICA, where she accelerates cross-sector digital technologies into the mining sector. She specialized in helping scale TRL6+ solutions and building strategic partnerships for adoptions. MICA is the Mining Innovation Commercialization Accelerator. It's a national innovation hub that supports commercialization of breakthrough mining technologies, enabling adopting through funding, networks, and technical validation. We would like to welcome Lorelei from MICA. Thank you, Lorelei.
Right, well, thank you, and hello, everyone. So, Lorelei Ratuszniak, I'm here to talk to you about some things happening in AI and how we can really accelerate the adoption of AI in mining. So looking at global opportunities versus AI in mining. So it's really kind of interesting with all of the developments happening right now. And you look at AI developments happening all around us and how Alexa or Siri talk back to us and how that was different from before, even Google searches, certainly in video games, and even in the arts industry when it comes to even how music is being composed. And it raises an interesting question that, do people realize that this wasn't here before? So it's certainly rapidly expanding in so many different industries outside of mining. And of course, every sector will be affected by AI. And the ones that are ripe for AI are the ones that are at the level of optimization, not reinvention and not transformation. And of course, we've seen this in healthcare and in agriculture. And under the optimization box, you can see there's an example of a company that has helped to optimize a certain process in the agriculture industry where it identified strawberries that weren't ripe and picked that off the line. So we're also seeing that there's going to be, certainly, there is a battle for talent and resources when it comes between tech platforms, AI startups, and established companies. So where does mining want to really fall when it comes to the adoption in AI? There's always two different groups. There's the early adopters and people who play catch up, right? The example of that is with the iPhone. So IT is certainly a challenge in mining because it's heavily regulated and IT has to approve technology coming in. In terms of waiting for data to be absolutely perfect, I don't think we can really do that. And interestingly enough, can we use AI to actually help with structuring data so it can help move that forward? People, very, very key when it comes to having them understand how to evaluate AI and technology, because at the end of the day, people can be gatekeepers. So you want to look at how we can really frame adoption in AI in the right way where it's not out of replacement or fear, but it really is seen as a gain. So if we haven't adopted everything from 10 years ago, can we keep adopting new things? In other use cases in startups, we have where AI tools are really implemented in these teams. And you could have a team of 50 people who are using AI tools, and they're almost working at the speed of thought. So they could actually be doing work at potentially the pace of a group of 400 people. So we do have to be open to AI and how it can really help to speed things up when it comes to the workforce. And now we have people who don't know how to code or don't have certain skill sets that are actually problem solving for things that have been typically outside of their education or skill set. Regulations. Europe is certainly advanced when it comes to regulations and in regulations in AI. So this will be very interesting for the mining industry, which is heavily regulated. So how are we going to really move through this with IT, with the regulations to really bring in AI and move that forward on adoption? What is the level of tolerance that we can have when it comes to experimenting with AI, but also looking at that AI is a potential. We don't entirely understand in some cases what it means, where our data is going, where the servers are, but yet we still consume. So this will be one of the challenges. An example of where it could be kind of painful for mining when it comes to training. So with Copilot, using this as an example, there's an enterprise that had a training program for Copilot, and you could not use Copilot unless you did the training. So this is where it's going to be interesting for mining companies to look at how can we bring in training across the organization with different skill sets at different levels to really make sure that we're balancing control and access to AI. And thus emerges kind of a shadow IT concept. Now there's a problem, right, where if we have tools within the organization that are approved by IT, but then we also have other AI profiles, which data is now sneaking out into these other AI tools. So this is going to be what we're going to have to look at. How can we have that level of control? Certain organizations are developing their own AI tools to really maintain the privacy and to have a better oversight with that. And so continuing on that, how do we determine the level of risk that we are going to really tolerate? It certainly means being balancing control when it comes to AI and looking at what truly is the worst case scenario. If we bring in this tool, what could go wrong? And in some cases, it is that, well, you might just have an extra 4 hours of work to do. So looking at that in a reasonable way can really help to look at what that risk is. So getting a little bit into the IT structure and architecture, right? AI evolves, it evolves very fast. And with IT, you look at setting up the corporate IT structure over at 5 to 10 years. And so if we bring AI into the organization and it evolves, it might not go with the current or previous technology standards. So how do we really look at where we could have more of a flexible model with that, without really compromising the standards within the organization? So it's very interesting. IT is, let's say, a large part of this. You need to have the right kind of model and leadership in place to really bring in AI to the organization. And the more specific we can be with problems, the better, right? A very specific input for AI, a very specific output. And there's been a lot of good cases of that. One of them is really being able to access information from maybe PDFs, and the georeferences is a real example. So it's very helpful in terms of productivity. And looking at this technology as really a tool in the toolbox. We can have a wrench, we can have a hammer. There's going to be people in different points in the process that are going to use this for really different things. But we don't have to wait for all these aspects to be perfect. And certainly, one thing that is really interesting that we're seeing more now is there are joint roadmaps being developed between IT risk teams and legal, because it's certainly touching all of those points. So if we could bring those three departments together, we can really look at how we can overcome some of these barriers. So the speed of adoption, do we keep implementing, or do we try and leapfrog? And analytics is still a nascent concept of some mining companies, right? And this is well over a decade ago. So it's fascinating because we also needed an ecosystem approach. If we don't have the engineering companies and the OEMs really bringing in certain technologies, this could have the mining companies go a traditional path if we're not also moving from an ecosystem approach. So are we going to get more adoption out of the solutions we haven't adopted from 10 years ago, or can we really just go past this point? And is AI the solution to help us do that? Getting into the vendor data centralization a little bit, and using Copilot again as another example. So companies who have implemented Copilot have found that it's great to really look in terms of a learning experience. What are some of the things we don't have in place? And companies have found that our data isn't structured properly, actually. And you don't want to be able to have people in the workforce searching things in SharePoint and access to information that they shouldn't have. So this is all part of really looking at how you can have the proper data structured to really bring this in. And again, having that joint roadmap between departments really is going to help to move that forward. And the current state for looking at vendors, a lot of companies still do use Excel sheets. There are some antiquated ways of looking at this. So how do we want to really be able to evaluate technologies better to be able to really move them forward in the organization? Just go over that slide, I don't have too much time here. And here is an example. It's just showing the workflow of 3 different ways that mining companies evaluate technology. The first one is a digital library, where you're looking at having information from vendors really accessible across sites, and there's a specific decision-making point using Microsoft lists. The center one is a bit more sophisticated, where it's been internally developed as an entire vendor tracking solution, where you're plotting different maturities of technologies in a quadrant, and you do have broader accessibility, but also certain key things in place so certain individuals can really look at that. The third one is Excel, and this really leads to the decision, do we build or do we buy? So there's different levels of maturity of evaluating technology. With MICA, one of the things that we do is we really help to look at the front-end process of technologies and gather information on how we do that. So we are looking at technology readiness level, the commercial maturity, what theme do you address, critical minerals, production, et cetera. How many installations do you have in mining, so we can get a better idea of the maturity, the stakeholders you're targeting, and what are the benefits from the stakeholders, as just a few examples. So wrapping this up a little bit. AI is becoming, has a much more human interface, which has certainly been helpful. You don't have to be the expert anymore. You don't have to have, in some cases, certain credentials to solve certain problems, which is really what's making this go rapidly within companies. And previously, you used to have engineers, data scientists who could only really solve certain problems. So this is really opening it up to the workforce in general, which I think is good for mining, but it also, of course, has some risks around that. And solvable problems in AI are in these 6 categories, right? We do want to look at, well, if we're going to solve problems with AI and mining, it does have to fall into very specific areas. And one thing to be careful of is if we are bringing in AI to mining, and let's say we're bringing in a bot, if the bot is going to give unintelligent answers, then this is going to affect the adoption of that as well. But we do have to have that tolerance as well when it comes to that there are mistakes going to be made, and there's a learning curve. So what needs to change and how we can really speed up adoption? Bring your own device is something that's happened a little bit in mining companies, but this is a good way to look at, to have a hands-on experience with the workforce, leadership, and really driving this from the top level to really look at how we can experiment together with AI in a way that is in alignment with the company. Gatekeeping can be certainly a challenge because of the fear of bringing in AI and also just not understanding it maybe at the level some folks should. So we need to make AI so mainstream that you don't have to have technical abilities to actually adopt it. And that's where you see the most seamless adoption of AI. But there's also, again, a risk that really comes with that. So which adoption group does mining want to be part of when it comes to this? And I think that really is the question right now. So thank you very much for listening to a presentation, open to questions, and to speak with you afterwards on how MICA can help you with AI and also vendor selection. Thank you.
Thank you, Lorelei, Director from Mining Relations at MICA. We have now 2 speakers coming into stage. Michael Machado, CEO of AYF, Experience Your Future, where he applies predictive, analytical, and digital twins to improve capital allocations, project development, and investment timing. And with him also, we have the pleasure to introduce Andrei Maliakov, which is a CEO of Amalgama and vendor of Mine Twins, a tool to create digital twins of mine through computer simulations. EYF, Experience Your Future, develops digital planning and simulation tools for mining, focused on improving strategic decision-making under uncertainty using AI, scenario modeling, and integrated data systems. Without further delay, please, Michael, come into stage and then you manage the show.
Thanks, everybody. We are actually handling here a presentation about a digital planning solution, especially for planning OPEX and CAPEX. I'm gonna show actually one case, and my partner here, Andrew, is gonna show a little bit more about MineTwin. We have a bunch of case studies that I can show you and share with you. We have both here in the event, but let's start here. So I've been working with advanced analytics, basically in simulation optimization, now prediction and AI solution, developing our own solutions for specific application in different segments, especially in the mining. Since 2007, I've been working with those kind of solutions. And Andre is a CEO at Amalgama. Amalgama is the owner platform of MineTwin. MineTwin is I think today MineTwin is the only tool in the market that combines discrete event simulation, linear programming, and combinatorial optimization, especially to build a realistic digital model that can become a digital twin of mines, including the planning scheduling solution. We have all those case studies that we applied in Latam. Most of those cases of success was applied at Vale, one of the biggest mining company in the world. We support Vale to save more than $300 million on those projects. The lowest return on investment on those projects was 45%. In many of those projects, the payback was less than 1 year. We support them during the project. It could be actually just one animation in that picture, but this case is for S11D, one of the biggest mining operation that Vale has in the north of Brazil. So we started this project with them in 2012, and now we're keeping working with them, especially with modeling, simulation, and optimization, now incorporate some prediction analysis as well. So here the objectives and motivation of the project. I don't have enough time to explain you, but especially in the mining consulting, use all those information that you can see here, the mining planning, the maintenance, life data analysis, equipment capacity, seasonality, granulometry, and all those information, like if you are the under capacity, over capacity, the production, the productivity, the physical availability, all those informations, we've got that. And they are using that solution for over 80 years, with saving that at least $100 million specifically in that operation. So I'm gonna pass to the Andrew that was gonna keep in and tell about MineTwin a little bit for you.
Thanks, Michael. I'm Andrei Malikanov, CEO and co-founder of Amalgama, company behind MineTwin simulation tool. This MineTwin simulation tool is actually one of the few tools that is specifically tailored for mining industry that uses computer simulation. I'm just trying to click through all the slides because we were just informed that we must be short with our presentation. So let me just get to my slides first, and then so what is the MineTwin? The MineTwin is basically the simulation model, and what is simulation model is a computer representation of all the mining processes that happen in above ground or underground mines. Unlike many other simulation tools, general purpose simulation tools, or the de facto standard simulations that mining companies use, we try to consider the entire mine and the entire processes of all the processes within the mine, like drilling, blasting, haulage, planning, etc. So unlike other simulation tools, we try to simulate all the processes that mine typically has. So who is MineTwin for? I would name 4 typical use cases for MineTwin and for simulation in general. First one is company plans to implement new technological solutions, and operational and financial impact of these implementation is hard to estimate. For example, let's consider something like railway or underground rail transportation system, how to consider whether or not it will be useful, what will be the bottom line, financially speaking, of that CAPEX initiative. Basically, the only way to answer this is to simulate and compare. Or the second one is mining plan is often not fulfilled or not adhered to due to suboptimal planning or insufficient allocation of equipment. And there are a lot of interacting bottlenecks. And again, the only way to explore this is through simulating the operations of the mine, or company can plan to estimate the reachable performance of a future mine, which does not yet exist. Here, that's the typical case for simulation, and simulation's been there for decades, but the problem is that they only typically simulate parts of the system, like the haulage parts of the system, but nobody simulates the entire mine. So that's where the mine twin kicks in with its simulation technologies. Or simply speaking, high costs of buying and operating the mining equipment. So we need to either optimize mining equipment fleet or to justify the purchasing of new equipment units. And again, here the simulation helps us. So here are the main stakeholders that can benefit from simulation. They can be direct users of that mine twin solution, or they can be just the stakeholders. It can range anywhere from strategic department when we plan CAPEX initiatives, all the way down to mine management and mining superintendents when we verify annual and weekly plans, for example, with the simulation, or investment committee where we are planning the options how to mine the new ore body that we've just discovered and starting mining. So why simulation? Once again, I will remind that simulation is actually what that is, and we have a booth upstairs, so you can approach us after this presentation in the break. So why simulation? Because in every mine, we started from the underground mining, and in above ground mining as well, there are thousands of cyclical dependencies and interacting constraints that are basically impossible to solve by static calculation, by the spreadsheet calculation, or even like linear or mixed integer programming methods, the traditional methods. So the only way to analyze these dependencies and to figure out what the real mining constraints are is through simulation, because simulation actually represents all that dynamics of how the mine behaves and allows us to play with a digital copy of the mine. So how MineTwin works, I will not read through all the details here. I will just say that MineTwin is probably the only tool in the market that combines discrete event simulation, which is where we started from, what we started from, with linear programming and combinatorial optimization. And I think the fourth component here should have been AI, I guess. Everyone speaks about AI now, so and we are implementing AI inside of that MineTwin simulation, that it can actually automatically generate guidance and advice to the users of what could have been improved in the real mining operation. So there are tools on the market that use these technologies separately, but I think MineTwin is probably the only one that combines them within a single solution. So what results typically MineTwin clients achieve? So we are, the MineTwin is being used all around the world, from Australia to North America, Central Asia, we are South Africa, and we are entering the South American market now. The typical examples of what can be achieved is just 10% cost savings, just because of the just because of the better understanding of the mining process, and by being able to purchase less equipment or to optimize the fleet configuration by buying the proper models of the equipment. That can yield into up to 10% of the cost savings, or reduced monthly planning error by 10%, or planning time as well by several folds. or increased mining volumes by 3 to 5% just due to more efficient equipment allocation, for example, distribution between production and development works, etc. So, and there are other numerous examples which we will be glad to talk with you about on our booth. And I think at this point I need to wrap this up. Thanks very much for the attention.
Thank you, Michael from EYF, and Andre from MineTwin. Certainly there will be lots of questions for them. Our last speaker today is Matti Shavani. He's a senior researcher from the Norwegian Geotechnical Institute. Matti works at NGI and is a technical lead for the Dynamine project, developing digital mine management platforms tailored to the unique constraints of small to medium-sized operations. NGI, as the Norwegian Geotechnical Institute, is a leading research and consultancy institute in geotechnics and engineering geology. And Dynamine project focuses on practical digitalization solutions for resource-limited mining operations. So thank you, Matti, to be here. And please, the floor is yours.
Good afternoon, everybody. Today I have a different audience. I used to talk more in academia and technical conferences, so this is my first time actually in a crowd as you are today, and it's a great honor actually. I want to start to talking about this issue that we mostly see at the developing digital technologies for mines. Or even new technologies for the mines. So most of the focuses today is on the material technology, on the processing. But the part that is forgotten actually is the part that people somewhere, they are moving some rock. And in nature of this work, if we check it, has not been changed since Iron Age. I mean, I'm just a bit shy to say since Stone Age, but since Iron Age, we can say. So we always digged some rock, crushed it, and melted. But if we think about it, the biggest advancement in this technology has been arrived when humans started using fire, and then after that was the dynamite. So nothing has been happened since that. And if we look at the Europe's current policy regarding the invisible mining, I mean, whatever you do is going to be a hole on the ground unless we go toward precision mining, to go toward the technologies that we touch or move minimum amounts of the rock. So the project that I'm presenting today is called Dynamine. It's more or less contains this kind of the thinking behind of it. So Dynamine project is a Euro Horizon innovation action, which with the budget over 11 million euro, which has a consortium consisting of the 11 European partners and from 6 different countries actually. So at the moment, Dynamine is demonstrating a smart and integrated mine management approaches. This consists of the one digital mine management platform, and then we have some real-time data which is communicated with that platform, and of course we utilize it to monitor and manage and mitigate risks from mine to the port. So we consider everything from the geology, from the start, from the rock itself, all the way until the door that we deliver or let's say concentrate to the customer. And the main issue here is more improve this selective mining and go toward the technologies which I believe should be, I love to call it actually precision mining. So we have 2 demonstration sites. One up in North Norway is a graphite deposit, which is mining the flake graphite. extremely good quality product, actually. And the second one is from here, Portugal, is a pegmatite mica feldspar deposit, which their CEO, actually, Brendan from MCS, he was a panelist yesterday. Then the question rises here, why do small to medium size matters? I mean, I think most of the presentation in this conference up until today was about the gigantic big mining companies, and everybody forgot these little guys. So to start with the numbers, they contribute over to the 50% of the total added value in the Europe's mining industry. And if you compare it with the other resource nations like Sweden or Finland, the story is different. If we go to Australia or to Canada, again, the story is different. But in Europe, the mines are small, so you cannot bring such huge machinery and the technology which is existing there and utilize them in Europe. And also these small mines, most of the time they are in a remote part, and they are contributing a lot to the communities and the regional economy. Of course, there is also always some issues with the local people. And also, I believe it represents a kind of the future toward mining, because we need to downscale the operation to like a precision mining. We do small activities which mines exactly what we need. We don't need to mine everything. So then, but they face major challenges in modernizing, and particularly in adopting digital and new technologies, which I'm going to talk why. So first and foremost is that these companies, they have a problem with the ore body. They mostly mine with the irregular and the complex ore bodies, which bigger companies, they wasn't interested in it. Majority of them, of course, they use outdated and legacy equipment, which has a limited capacity to be adopted with the new technologies. And of course, these people, they have a problem with the hiring skilled workforce. So imagine if I want to use, let's say, a leapfrog software, which is used for geomodeling in a mining company. I need to hire a person with a master's degree in, let's say, geology, which trained during the studies to utilize such a program. And then after I have to hire them and they give them a good salary. But small-scale mining, they don't have such a luxury. They cannot even afford to hire such a person. And of course, for most is their financially, they have some limited capacity. So then the Dynamine solution, which is practically we developed at this EU project, and as soon as we are going to hit the market with some spin-out company, is about first developing a database which gathers all the required data from geology, environment, economy, and other mining aspects on one specific database. And then this is deployed in cloud, so we can have some kind of applications connected to it, talk with this, and then easily you can share it with the entire stakeholders. And of course, we can optimize it according to the requirement of our customer, whatever they need, depending on their, for example, since small mining companies, they have like specific need. They are, in terms of the complexity, they are very different. So we have this ability to kind of adopt this technology for their specific need, which can contain something like from their processing plant. In some detail, we can monitor it and we can include it in our assessment up until their vehicles and, of course, their drilling machine. But when it comes to the deployment, we deploy it in the cloud. Of course, it has a modular architecture, as I talked about it, and it is specifically designed for a functionality that can be used in the small to medium size. But one of the most kind of like interesting feature of this technology is that it is easy to learn. So the users, the operators that mostly are working at the mine, we are planning to educate them, to train them just for a day or two, and after that they will manage to utilize such a tool without any help from the external people. And of course, this has a rapid scalability, and also we are looking for some alternative financially adaptation with the small to medium mining companies. I don't have too much to share now. Thank you for your patience. And I would love to, if you guys check our project, that QR code that is there, you can follow us there. And I hope next time when I'm here, I can show you exactly our technology, how it is working with some successful cases in small to medium-sized mines. Thank you.
Thank you, Madi, from the Norwegian Geotechnical Institute. I think it's time to recap. So as the European Union prioritize resilient and sustainable and more traceable raw material supply chain, I think this session has been able to showcase how digital innovation works, from product passport that was introduced as the first speech, to planning algorithms and distribution ledgers. So I think how this is redefining how the materials or the raw materials move from the mine to the market, and how the market is demanding these type of tools to, let's say, upgrade mining into the 21st century. So thank you very much for the contribution. I think we do have a very limited time for questions. I've had some questions already for the speakers, but I will try to catch up later. And I hope today's session has sparked new ideas around how digital transformation can reshape not only operational efficiency, as it has been demonstrated, but also trust, environment, sustainability, and governance performance, and obviously policy across the mining value chain. So thank you very much to all the speakers, and please acknowledge their presentation. Thank you very much. I've been told that there is no coffee break now, so we will have a very small break and then immediately get into section 7 or 8, sorry. So if in between, if there is any questions to our speakers, please feel free to come and then we can discuss directly here. Thank you very much.